China is building entire skyscrapers in less time than it takes most people to paint a room. A 10-story apartment building, 28 hours, done. Walls, windows, pipes, wires, balconies, everything. A 57-story skyscraper, 19 days. A 26-story tower, 5 days. These are not shells or frames. They are complete buildings where people actually live. The man who figured out how to do this had never built anything in his life. He sold air conditioners. What pushed him into construction was one of the worst earthquakes in modern history, and he is not alone. A second company in China is doing something even stranger. They are printing houses with giant machines, the way you print a document on paper. What you are about to see is two completely different methods that are flipping the construction industry upside down. The speed is shocking enough, but what happens after these buildings go up is what really blows people away. If you like stories about technology changing the world, please hit that like button. These videos take a huge amount of effort to make, and subscribing means you will not miss the next one, because the story gets even wilder from here. The buildings going up this fast are not flimsy demo models. They are engineered to outlast almost everything else on your street by centuries. And the reason they work so well traces back to a single question one man asked while watching his television screen, a question that would end up changing how entire cities get built. The earthquake that changed everything. Zhang Yue was not a builder. For most of his career, he ran a company called Broad Group. They made air conditioning systems, big ones, for big buildings. Zhang Yue was good at it. His company grew into one of the largest air conditioning manufacturers in all of China. He had no reason to think about buildings. He had factories to run, orders to fill, and a business to grow. Construction was someone else's problem. Then 2008 happened. In May of that year, the ground shook in Sichuan province, an 8.0 magnitude earthquake, the kind that does not just rattle windows, but turns entire cities into dust. Close to 70,000 people died, not in slowly collapsing buildings, in buildings that just came apart, schools full of children, hospitals full of patients, homes where families were eating breakfast. Concrete walls that were supposed to protect them became the thing that crushed them. Zhang Yue watched the news and could not shake one thought. The buildings did not fall because they were old. Many were built recently. They fell because concrete has a fatal flaw. When the ground moves, concrete does not bend. It breaks. And when it breaks, there is no warning. No creaking, no swaying. Just a crack, and then everything comes down at once. The material that the entire world uses to build homes was never designed to handle that kind of force. Most people would have felt sad and moved on. Zhang Yue asked a different question. Why is the whole planet still building with this stuff? He could not find a good answer, so he did something radical. He took his entire company, his engineers, his factory workers, his money, and he pointed all of it at one goal: build a better way to make buildings. Something fast, something strong, something that never needs wet concrete poured on a construction site. He did not start by looking at what builders already did. He started from nothing, from the most basic questions. What does a building need to do? Stand up, stay standing, be comfortable, last a long time. That is it. Everything else was open to debate. He hired people who had never worked in construction, people from aerospace, people from car manufacturing, people who knew how to build complex things inside factories, over and over, with perfect accuracy. He did not want to improve construction. He wanted to replace it entirely. It took years, failed designs, joints that broke, systems that looked good on paper but fell apart in testing. But Zhang Yue kept pushing. He had seen what bad buildings do, and that image does not leave you. When the system finally worked, it did not just work a little. It worked completely, and the way it works is unlike anything the construction industry had ever seen. A building like a Lego set. Here is the idea. Instead of building a structure piece by piece on an empty lot, you build every single part inside a factory first. Then you ship the parts to the site and snap them together. Think of it like a giant Lego set. Every piece is made in the factory. Every piece fits perfectly, and on the site, you just connect them. The Broad Group factory is enormous. It covers 230,000 square meters. To picture that, imagine 32 city blocks of nothing but assembly lines and welding stations and paint booths. Inside, workers build sections of buildings that are about the size of shipping containers. But these are not empty boxes. Each one comes with walls already painted, windows already in place, electrical wires already running through, water pipes already connected, balconies already attached. When a section rolls out the factory door, it is a finished room, not a frame, not a shell, a room where someone could plug in a lamp and go to sleep. On the building site, there is no mixing cement, no waiting for things to dry, no worrying about rain, no crews of different workers showing up on different days doing different jobs. The site is just a place where finished rooms get lifted by cranes and bolted together. Steel pins lock each section to the ones around it. The whole process looks like someone stacking giant blocks, except the blocks have plumbing and electricity already inside them. Here is why this matters so much. When you build the old way, you are basically making everything from scratch, outdoors, in whatever weather shows up that day. The quality changes depending on who is working, how tired they are, and whether it rained last night. In a factory, none of that is a factor. Every section is built the same way, checked the same way, and shipped only when it passes inspection. You are not guessing whether something fits. You know it fits because it was measured and tested before it left the building. Broad Group wanted to prove this was not just theory, so they set up cameras in the city of Changsha and filmed themselves building a 10-story apartment building from start to finish. 3 cranes, 1 crew, constant filming. The foundation was already in the ground. The clock started when the first section came off the truck. It stopped 28 hours and 45 minutes later, when the last bolt was tightened on the top floor. A complete building, 10 stories, less than 29 hours. The video hit the internet and spread like wildfire. Millions of people watched it in days. People who had spent their whole careers in construction did not know what to say. Some called it the future of building. Others said it was a trick, a stunt that would never work in real life. But everyone watched it more than once. Broad Group did not argue with the critics. They did not write a press release. They just built something bigger. Going taller and faster. The next building was not 10 stories, it was 57. They called it Mini Sky City, and it rose 204 meters into the air. Inside were 800 apartments, office space for 4,000 people, and stores at the bottom. Every part was built in the factory. Every part was trucked to the site. Every part was bolted together, and the whole thing took 19 days. Think about what 19 days means. A building that tall, built the normal way, takes about 2 years. That is not a guess. That is the standard timeline for a skyscraper of that size. Broad Group did it in less than 3 weeks. A crew of 1,200 workers put up 3 floors every single day. Sections arrived by truck in a constant stream. Cranes lifted them into position in a steady rhythm. Workers on each floor locked everything together and then climbed up to do it again. More than 90% of the building arrived finished. The workers were not building, they were assembling. Here is something that gets lost in the speed. That one building replaced about 15,000 concrete truck deliveries. If you do not know what 15,000 trucks looks like, imagine a line of vehicles stretching from one end of a city to the other. That is how much concrete would have been poured, truck by truck, for a building this size. All of it eliminated. No cement mixing, no waiting for it to cure, no trucks idling in traffic. Mini Sky City changed the conversation. Before it, modular construction was seen as interesting but limited, good for small buildings, maybe a few stories, not for skyscrapers. After it, developers started asking questions they had never asked before. City planners started looking at their project timelines differently. Investors who had never thought about construction methods started paying attention. Then came the Jingdu building. 26 stories, just over 5 days, about 100 workers on site. That is a crew so small they could all ride to work on the same bus. They built a tower taller than most apartment buildings in any major city, in less time than a school week. No army of workers, no months of planning. No delays from bad weather, just 100 people, some cranes, and a steady flow of finished rooms arriving from the factory. At this point, the argument was over. The buildings were real. People were living in them. The video evidence was public. Nobody could say it did not work. But a new question took over the conversation. If a building goes up in 5 days, is it safe? Would you sleep on the 20th floor of something that was built in less time than it takes to grow a beard? The answer is the part that surprises everyone. Stronger than anything on your street. The steel used in broad group buildings is 10 times lighter than concrete. It is also 100 times stronger when you put weight on it. Those are not numbers from a company ad. They come from the China Academy of Building Research, which tested the materials independently. Every broad group building is rated to survive a magnitude 9 earthquake. If you are not familiar with the scale, a magnitude 9 is among the most powerful quakes ever recorded on Earth. It is the kind of event that levels entire regions. The expected lifespan of these buildings is about 1,000 years. Read that again. The building that went up in 28 hours is designed to outlast almost every concrete building being built right now by 10 times. Most concrete buildings are made to last 50 to 100 years. That is the number engineers calculate when they start pouring. After that, the concrete starts breaking down. Steel modular buildings, if they are maintained, can stand for 10 centuries. The reason comes down to how different materials deal with stress. Concrete is stubborn. When you push it, It pushes back until it cannot anymore. Then it cracks. And once concrete cracks, it keeps cracking. It does not heal. It does not recover. Steel is different. When you push steel, it bends a little. When you stop pushing, it goes back to its original shape. During an earthquake, that difference is everything. A concrete building resists until it shatters. A steel building flexes and sways and then settles back down. The bolted connections between modules act like joints in your body. They absorb movement instead of fighting it. There is one more thing that makes this system different. Because everything is bolted together, it can also be taken apart. At the end of a building's life, every section can be unbolted, loaded on a truck, and used somewhere else. Or the steel can be melted down and made into something new. Construction waste on a broad group project drops by more than 90%. No piles of broken concrete. No heaps of scrap metal. No dumpsters full of wood and wire. Just clean steel that goes right back into the system. The speed gets all the attention. The safety numbers get engineers interested. But the environmental story might be the most important part of all of this. Construction is one of the biggest sources of waste and pollution on the entire planet. A method that cuts waste by 90%, removes thousands of concrete truck trips, and creates a building that lasts 1,000 years is not just a faster way to build. It is a completely different relationship between building and the natural world. But Broad Group is only half the story. While they were stacking steel modules in Changsha, another company in Shanghai was trying something that sounds like it came from a movie. Printing houses like newspapers. The company is called Winsun. Their method does not involve factories or cranes or steel bolts. They print buildings. Imagine a regular printer, the kind that sits on your desk and puts ink on paper, line by line. Now imagine that printer is the size of a warehouse. Instead of ink, it uses a mix of recycled construction waste and fast-drying cement. Instead of paper, it prints walls, layer after layer, row after row. Slowly, a building rises from the ground up, built by a machine, following a digital file. In a single day, Winsun printed 10 complete houses. Each one was ready to move into. Not shells, not frames, actual houses with walls, roofs, and interiors. The material cost drops by 30 to 60% compared to building the normal way. The number of workers needed drops even more. And because the printer reads from a computer file, you can change the design for every single house without changing anything about the machine. Want a different layout for house number 3? Change the file. The printer does not care. It just follows the new instructions. This is where printed construction starts to do things that regular buildings simply cannot match. A skilled architect can draw a building with curves and odd angles and flowing shapes that would cost a fortune to build by hand. With a printer, those shapes cost the same as a plain straight wall. The machine does not charge more for fancy designs. It lays down material the same way no matter what shape you ask for. That opens up a world of creative possibilities that the construction industry has never had at normal prices. The uses go far beyond China. Think about places where building homes is too expensive for regular people to afford. Places where families work full jobs and still cannot buy a house. Printed construction can drop those costs dramatically. Think about areas hit by floods or storms or earthquakes, where people need shelter immediately. A printer can set up and produce sturdy structures within hours of a disaster. Think about rural communities in parts of Africa and Southeast Asia, where there are simply not enough trained builders to construct things the old way. A printer does not need a crew of 50. It needs a few operators and a digital file. Winsun and Broad Group are doing completely different things. One builds sections in a factory and bolts them together on site. The other squirts material out of a nozzle and builds from the ground up. But the core idea is the same. Stop building by hand in the open air. Move construction into systems where everything is controlled, repeatable, and precise. Where quality is built in from the start and waste is eliminated by design. Both companies are solving the same problem, and both are sitting inside a market that is growing much faster than most people realize, for reasons that go far beyond cool machines. Why most of the world is stuck. The world needs about 100 million new homes right now. That number is going up, not down. Construction costs are rising everywhere. The number of people who know how to build is shrinking. In the United States, the average construction worker is over 40 years old. Not enough young people are entering the trades to replace the ones who are retiring. Cities are growing faster than homes can be built. Rents keep climbing. Waiting lists for affordable housing stretch years into the future. The technology to fix a big part of this problem already exists. It is not on a drawing board. It is not in a lab. It is standing in cities across China, full of people who live and work inside it. The global modular construction market was worth about $95 billion in 2025. By 2034, it is expected to pass $175 billion. Asia holds about 45% of that market, and it is growing faster every year. China alone has committed over $1 trillion to infrastructure, and more of that money is going toward fast, efficient building methods. Other countries are moving too. Singapore now requires modular construction for public housing. The United Kingdom has put billions into factory-built programs. Japan and South Korea are scaling up their own systems. The money is real. The government support is real. This is not an experiment anymore. So why does most of the world still build the same way it did 50 years ago? The answer is not about technology. The answer is about everything else. Building codes in most countries were written for concrete and wood. They do not cover steel modules that snap together in a factory. Changing those codes takes years of testing, meetings, and political fighting. Supply chains are locked in. Cement companies, trucking companies, equipment rental businesses, all of them depend on the current system. They have no reason to help change it. Developers are nervous. If they try a new method and it fails, they lose money, so they stick with what they know. Workers have concerns too. Modular construction needs fewer people on site. That is part of why it is faster and cheaper. But it also means fewer jobs for the workers who have spent their lives building things the old way. That is a real problem. You cannot just tell someone their job is outdated and expect them to cheer for progress. Any honest look at the future of construction has to include those people. Broad Group once planned a building that would have been one of the tallest on Earth. It never started. Not because the engineering was not ready, because the rules, the permits, and the financial systems were not ready. The gap between what we can build and what the rules allow us to build is the real story here. Meanwhile, China puts up a 26-story tower in 5 days. A similar building in London or New York takes 3 years from the first paperwork to the first set of keys. Same planet, same decade, totally different worlds. The question is not whether this technology will take over. The economics make that almost certain. Less waste, shorter timelines, fewer workers needed, longer-lasting buildings. Every pressure the industry faces points in this direction. The real question is how long the gap stays open. How many families wait years for a home while the technology to build it in a week already exists? How many cities fall behind while the tools to catch up are ready and waiting? A man who spent his life making air conditioners watched an earthquake destroy 70,000 buildings and asked a simple question. Then he built a factory and changed everything. Someone else pointed a giant printer at a pile of recycled rubble and made 10 houses in a day. The new way is faster, stronger, safer, cheaper, and better for the planet. The only question left is how long the old way holds on. If this is the kind of story you came for, hit that like button, subscribe, and turn on notifications so you never miss the next one. There are more videos on the screen right now if you want to keep going. Here is something to think about. If a building that went up in 28 hours is rated to last 1,000 years, what does that say about every concrete building on your street? Leave your answer in the comments. We read every single one.